In this video, I am going to explain the number system concepts. So, number system is defined as a system of writing for expressing numbers in mathematical notation for representing numbers of given set by using digits or other symbols in the consistent manner. So normally we are using four different type of number system in digital electronics. First one is decimal number system. It will be represented as a base 10 number system. Binary number system is a base 2 number system, and octal number system is a base 8 number system. Hexadecimal number system is base 16 number system. These four number systems are commonly used. So in decimal number system, decimal numbers use a 10 and it will be represented as a 10 digits from 0 to 9. So every position shows a particular power of the base of 10. So for example, we can consider 5679. So each position will having its own position weight and it will be represented in the decimal manner. So for example, 5 representation is 5 into 10 power 3. So it will represent it as a 5000, and 6 into 10 power 2 is a 600. Then 7 into 10 power 1 is 70, and 9 into 1. So it's 9. So it will be represented in the decimal number in this manner. In terms of binary numbers, it will be always represented as two digits, either 0 or 1. Normal binary number, if it's a 1-bit number, you can represent 0 or 1. In a 2-bit number, you can represent 1 0 1 1 0 1 or 1 1 like that. In terms of 3-digit numbers, you can represent 1 0 0 1 0 1 1 1 0 1 1 1 like that. In 4-bit numbers, you can represent a 4-bit representation 1 0 0 0 1 0 1 1 1 1 0 0 like that. So every position having a particular power of base 2. For example, if 1010 means it's a first position is represented as a 1 into 2 power 3, it will be represented as 8, and 1 into 2 power 2, it will be represented as 0, because here the digit position is 0, so it will be 0, and 1 into 2 power 1, it will be represented as a 2, and 0 into 2 power 0 is a value is 0. So like that it will be represented in the successive multiplication manner, and all the values will be summed and we can get a decimal number. Its value is equal to 1010 will be binary, and it will equal and decimal number equal to 10. An octal number system, it will be represented as a base of 8 number system, and it's having a 8 digits 0 to 7. And the octal numbers, it's sequential numbers from decimal numbers from 0 to 7 in 1-bit representation. And in terms of 2-bit, it will start from 10 and 11 like that. It will be up to 17. Then it will move to next value of 21 like that. For every position shows a particular power weight of base of 8. For example, we can consider 376. So it will be represented with the position weights of 3 into 8 power 2. It will be represented as a 192, and 7 into 8 power 1 is a 56, and 6 into 8 power 0, it represents 6. So it will be a equivalent value of 256 decimal value. In terms of hexadecimal numbers, the numbers will be represented in terms of base 16 numbers, and it's having a 16 numbers, and it will start from 0 to 9 in a decimal numbers, and also it will be represented as alphabet A to F. So totally we are having a 16 numbers. It will start from 0 and end at decimal number 9, and it start A to F in 1-bit representation. In 2-bit representation, it will be represented as 1011 like that. So every position, it have a particular position weight in the base of 16. So for example, if you are considering 392 and 39A, 3 into 16 power 2 and 9 into 16 power 1, and a value is equal to 10. So a into 10 16 power 0 like that it will be represented, and all are multiplied and summed. We can get a 922 is a equivalent decimal value of the particular hexadecimal 39A. And if you want to convert that numbers from one number system to another number system, as the easiest understanding number system is a decimal number. So we start with first decimal to binary conversions. Normally the decimal to binary or decimal to octal or decimal to hexadecimal, these all the number conversions are used common method is called as a successive division methods. So we are dividing the required number base value in the given decimal numbers. So each time it will be divided, and each step by step what is the remainder will be, that will be represented in the right side, and the remainders all are clubbed from bottom to top approach. So we are getting the corresponding binary equivalent number. And if the binary number is given, you want to convert into decimal, means you can follow the successive multiplication method for the base of the given number system. So you can convert 111001 into decimal number, multiply the position weight of each bit, and adding all the product will give this decimal equivalent number. So each position weight will be multiplied with the given number. So and it will be summed. So in that condition you can consider 111001. So first one is it's a most significant bit, it's having a highest position weight, so it's having 2 power 5. So it will be multiplied with the given number. Then 2 power 4, 2 power 3, 2 power 2, 2 power 1, and 2 power 0. Like that, each bit will be having its own position weight, and it will be multiplied with that number and summed all the numbers. Then we can get a 57 in a decimal equivalent value. In terms of fractional numbers, if the numbers having real numbers and fractional numbers, you want to convert first real number as per the normal number conversion in successive division method, and that fractional numbers will be converted based upon the multiplication of the required number base. So the fractional number multiplied, and we are getting if the real number, that value will be considered as a equivalent binary value. And here 0.75 into 2, the require is base system, so into 2, so we are getting 1.50. The 1 will be taken as a value answer, and again the fraction value is again multiplied with 2, then we are getting 1. Then the process stopped, because the further fraction number is 0, so we are going to stop this process. So we are getting the answer is 0.11. So like that, the fractional numbers are converted into a binary equivalent numbers. And fractional number, for example, the given number is binary number, we want to convert into decimal number, means same thing, the real number will be as per the successive multiplication with the positional weight, and fractional numbers also considered in the position weight, but the fractional numbers having a position weight in the negative manner. So the 10001.11, you can get a 17.75 is a equivalent decimal number.